Cool. So my friend Mike has this tattoo on his arm of a floppy disk. And we were just chatting about it, and then we were sort of thinking big data. You know, everyone's talking about that, and we wanted to get back, and we were talking about small data, you know, and artisanal data. And it got me back to remembering my first floppy disk, which was a lot like this one. Unfortunately, I don't have my first ever floppy disk, which is a shame. I would love to have that. And it was about sometime sort of in the mid-90s, early 90s actually, and I was given this disk. And I was a bit unlucky because at school I was allocated the computer. It was on the end of the row, and it was a bit temperamental, apparently because it got a bit too cold because it was close to the window. And so I was given a 5¼ inch disk, where everyone else got a 3½ inch disk, and it only held 360 kilobytes, which even back then was not a lot of space at all. And anyway, I became very fond of it, and so we were talking about these disks, and I was also remembering there was this other time. On August 11, 1999, in the UK, there was a solar eclipse, and we were quite near to the path of totality. And we ripped apart all these floppy disks and went outside, and we were using those to sort of shield ourselves against the sun, which isn't a recommended thing, by the way, and actually also isn't very good for using that. But we were talking about it, and it just made me think about how the floppy disk really was sort of the last kind of thing where you actually were there, and the data was just in front of you, and you could touch it, but you couldn't see it. And often we did touch it as well. It was a bit weird. I don't know if it seemed almost everyone did that. If you had a floppy disk, you always had to pull back the metal thing and just poke your finger onto the disk. I don't quite know, what we're expecting to find in there, or, we do sort of always pull it back just to check in case someone had stolen a magnetic disk out from inside of there. So anyway, so I wanted to actually think what did the data look like on the disk? And is this working? Yes. So I built this, which is not super accurate. Whoops, cats. And so it doesn't show probably all that well. But the disk works by having there's this little hole here which sort of indicates when it's spinning round as to exactly where it is on the disk. Actually, I've got this version. So that shows it a bit more clearly. So you don't know if you know anything you might know about disks, but a disk is divided up into tracks, which are these sort of rings going out from the center. And then it's divided into sectors, which are kind of like the little pizza slices which go in there. And this is modeled on that disk because it's a smaller size, so it's much easier to see on this screen. But even on a normal sort of 3½ inch floppy disk, there's 80 tracks and 18 sectors, which surprisingly is still, when I started drawing this, I was surprised at how much that actually is to draw. It's already, even on very old technology like this, the data density is very high, and it's very difficult to actually draw that on the screen. And also coincidentally as well, I found that 18 sectors with 80 tracks is actually 1,440, which coincidentally is the number of minutes in a day. And I was thinking that would actually make an interesting clock, but I didn't get around to building that. So anyway, the way, this is a very sort of simple explanation of it, which is using somebody's made a FAT12 JavaScript library, which I was very thankful for, made this a lot easier. And so we have like the boot, this is actually, wait a sec, I always get confused here. So yeah, this is the master boot record, and then this is the boot sector, which you've probably heard about, when disks won't boot and things like this. And then we've got this blue bit here, which is the FAT table, and then the whole thing is duplicated again, so that there's sort of a little chance of recovery if things go wrong, which probably if you've ever had a floppy disk, they quite regularly did. Then the green bits are where the sort of directories are, and then the files are written out on the grey bits outside. And so I wanted to go further than that still, and I wanted to actually look, how does the actual bytes would look, and the bits on the disk. And let me try this one. And so that's just draws quite quickly. But so this is actually showing each individual bit, and it takes a long time if we want to draw them properly, so I sort of rendered these ones out in advance. But this one's quite interesting to look at. And so you can actually look at the individual bits of each on the disk. It looks a lot better on my screen. And I thought it was interesting to kind of think about the data and where it's actually stored and how it's stored, because often when you are trying to to debug a problem, you have to really kind of think about what are you actually doing. The data is representing represented by this binary, and what does that actually look like? That can often help, I find, with problems. And that was it largely. And I actually found there was someone had used an electron microscope to do it the physical way, which works too. But I was pleased that it did actually kind of look similar. Thank you.